Hello, guys. Good morning. Welcome to the session today.
Yeah, good morning, sir.
Hope you all can hear me today, right?
Yeah, yes, able to hear.
Great. Let us start the session. So, if you remember last time what we have discussed, let me tell you one thing. So, as a data engineer, we were having two challenges. One was storage. One more was okay, I have notes. Let me open. Okay. If you can see here, as a data engineer, we were having two challenges. One of the challenge was storage. So if we wanted to store 100 GB of the data, we were using a distributed system, nothing but a cluster. So we have one of the solution that is HDFS. HDFS is nothing but a Hadoop distributed file system. What it will do is that it splits the data and distribute the data to the multiple machines in a cluster. Okay. What is a cluster, sir? A cluster is nothing but a collection of machines or a nodes. And this way, so if you have any amount of data, you can able to store with the help of the HDFS. So storage challenge was fixed, and after that we have a processing challenge, the computation. So from the Hadoop we have a one more solution, that is MapReduce, which is a programming model or a processing framework used for large scale data processing. Okay, the same thing here also it will happen. A map reduced model, what it will do is that whatever the data, whatever the processing that it needs, right, it's gonna be splitting that processing task to the multiple machines, and all these tasks or all these independent tasks will be done in multiple machines. So that's where it is called as a parallel processing engine. Okay, so MapReduce was written in Java. People are unable to write the Java code for the data processing. And not only that, MapReduce was only for the batch data processing. We cannot be able to do the streaming data processing. And one more thing is that MapReduce do the data processing with the help of the disk-oriented manner, which is very slow. So that's where we have a Spark. Spark is a Spark is actually taken from Spark code is actually referenced from the MapReduce only, and it is also an open source distributed parallel processing engine similar to the MapReduce. The only thing difference is that Spark offers multiple language support, nothing but a client library support, where you can able to do the data processing with the help of the Java, Python, R, Node.js, all of these things, Scala, and it supports in-memory computation, because when you do the computation with the help of the memory, it will be very faster, and it supports batch plus streaming data processing as well. Okay, so that's where whatever the challenges that we were facing with the MapReduce, which was totally fixed by the Spark. So that's the reason Spark took over the market of MapReduce. Now Spark become very famous when it comes to the batch data processing or a streaming data processing. Okay, so what is Pyspark now? So Python become very famous because when it comes to the data processing, Python is very heavily used. Now, when we already know that the Spark has its own library and its own processing framework. When Python used with the Spark, that's why people call it as a PySpark. Nothing but a Spark library written in Python. Sorry, Spark library written in Python is nothing but a PySpark, sir. Spark library. Okay, Spark library written in Python is nothing but a PySpark. Okay, so when you use the Spark with Python is nothing but a PySpark. So you can able to use PySpark for data processing now. Okay, so you can also use Scala with Spark. You can also use Java with the Spark, R with the Spark. But PySpark is very famous. It's because many people already know the Python, and it's very easy language to learn and very easy to process the data. Okay, if you wanted to see here, so you can able to see the difference between the MapReduce and Spark, which I have already told you it's the same thing. And the Spark, what is a Spark? I told you already. It is a in-memory computation, distributed data processing, and it is a parallel processing engine. Okay, and the fault tolerance, lazy evaluation is there. Open source supports multiple languages. Batch data plus real-time processing, 100 times faster than the MapReduce. Okay, so if you wanted to use the Spark, this is how it looks like. This is how it looks like, guys. So for example, so if you need a storage layer, you can use HDFS, or you can use Amazon S3 buckets, Azure blob storages, or you can use Google Cloud Storage. Okay, because you need to store some data somewhere. Spark is a computing engine, and Spark is a programming framework. But if you need to do the data processing, you need to have some data stored in some layer. So if you wanted to store some data, you can actually store it in any of these tools. And the cluster manager. What is a cluster manager? Let me try to tell you what is a cluster manager now. So try to understand this point. See, you have a cluster. In a cluster, you will be having master. You will be having worker 1, worker 2, worker 3. Hope you all can hear me, right? Now, what will happen is that, see, you do not have only single job. Okay, you may be having multiple jobs. So, job 1, job 2, job 3, job 4. Okay, so you need someone to look after your cluster. You need someone to look after your cluster and check what are the machines are available for taking care of taking these next jobs. So you think like you all have submitted job one and job one was running in the cluster. Okay, job one was running in the cluster. And you have a job two, you submitted it, job two also running in the cluster. When you submit the job three, you need someone to look after your cluster and check the status of the cluster and which are the machines are available. And if the machines are available to take the next job, and it will be submitting the job three will be submitted to those idle machines or those vacant machines to complete this next task as well. So that's where the cluster manager come into the picture. Very famous now. So because what the cluster manager will do is that cluster manager is the one. Yarn. Yarn is a famously used cluster manager. What it will do is that it will allocate the resources according to your jobs. What it will do, it allocate the resources. See, for example, you have a job three. What it will do, cluster manager yarn come into the picture and it checks whether the machine one is idle or whether the machine two can able to take care of the next task, machine three can able to take care of the next task. It will check all the machines, and if one of the machine is taking care of, one of the machine can able to take care of this job, it will be submitting the job to this machine. So that's what the cluster manager do. Okay, so a cluster manager is nothing but a resource allocation tool. Okay, now sorry. So you can use cluster managers either Yarn or Mesos or Kubernetes. Anything you can use. Okay, what it will do is that it will look after the cluster and it will try to allocate the resources for the jobs. And the Spark engine. Now, whatever the whatever the cluster you will be having it, right, the cluster will it totally maintained by the Spark engine only. Okay, so Spark engine will be doing the Spark data processing. So whatever the code you wanted to write it, you can write it in with the help of the Scala or Python or Java or R. So you submit that code to the engine, and the engine will be doing the data processing, and the data is here, cluster manager is here, and the Spark engine is here. You submit your code to the Spark engine, and you whenever you submit the code to the Spark engine, it will be doing the data processing by getting the data from the storage layers. Okay. Spark has four components. One is SQL, one more is streaming data, machine learning library, graphics. And it has three APIs: RDD, data frames, data sets. Out of this one, data frames is nowadays very heavily used and which is very important for us to learn. So we are focusing on this thing only. Okay, data frames. Okay, this is the architecture of the Spark, guys. In the Spark, you will be having a storage layer, you will be having a cluster managers, you will be having a compute engine, you will be having a client library support, and the four components are also there. Spark supports SQL, Spark SQL, Spark streaming, Spark machine library, Spark graphics. Okay, those who wanted to do the machine learning models, they can do it. Those who wanted to do the streaming data processing, batch data processing, they can able to do it. Those who wanted to take care of the graphics relationship kind of a thing, they can also go for it. Okay. So now what is a data proc? Okay. So far this is what all the things related to the Spark, MapReduce, as well as HDFS, Pyspark, all of those things that we have learned. But what is data proc? So data proc is, see, why data came into the picture is that, see, when people were trying to use it like this, okay, so if they wanted to create a cluster manually, what they are trying to do is that they are creating a cluster of machines, machine 1, machine 2, machine 3, master, worker. Manually, they are creating the cluster in the companies. In the on-premises, they are manually creating the cluster. If they are manually creating the cluster means this master, all of these machines are readily available over the network. Storage of these machines has to be taken care. Backup of these machines has to be taken care. Infrastructure for these machines has to be taken care. Networking for these machines has to be taken care. So that's where people are unable to manage this cluster in the on-premises. They were looking for a solution. So that's where Dataproc, Databricks, Databricks, and EMR came into the picture. So what they try to do, you don't need to create a cluster manually. You don't need to take care of the storage. You don't need to install these softwares. You don't need to install the Spark. You don't need to install the MapReduce. You don't need to install the HDFS. You don't need to worry about the backup. All the things will be taken care by these tools. Okay, you can just focus on where, sir? You can just focus on PySpark code, or you can just focus on Scala code. So what they try to do, people were facing a lot of problems. For example, if you are working in an on-premises, right, this is how it will be. So for example, if you wanted to work in an on-premises and you wanted to do the data processing, this is what you wanted to do, sir. Assume that you wanted to do the data processing, and so that you will be able to have a clean data which you can send it to your data warehouse for the analysis purpose. Okay, which you can do it, send it to the analysis purpose. But if you wanted to do the data processing, you need to write your code. Okay, you need to write your code. If you need to write your code, you need to have Spark or MapReduce or HDFS to be installed on top of the systems. But where are these systems? The systems has to be available. That is what we call as a cluster. So master has to be available, worker has to be available. Tomorrow, if you wanted to scale it, you need a one more worker. So you need to have all of these machines has to be installed, and after that you need to have all the software to be installed. So if you then you can able to prepare your code and do the data processing. Okay, so until then you can't do anything. So you need to create a master machine, or you need to create all these worker machines and take care of the storage, infrastructure for the cluster, storage of the cluster, backup of the cluster, networking of the cluster. Likewise, many other things are there. Okay, so all of these management details you have to take care of it. So if you wanted to create a cluster in the on premises, you need to take care of many things, and after that, once the cluster is created, you have to again still create the install the Spark, MapReduce, and HDFS on top of all of these machines. So that's where it it takes a lot of effort, lot of infrastructure, a lot of money is spent on top of this one, and we need a skilled person to take care of these things, which people unable to don't wanted to take care of it. They were looking for a solution. So all of these things are replaced by the data proc, data bricks, and all of those things. Now one of the solution is a data proc. What is this data proc? Is that data proc is a managed Spark and Hadoop cluster. So managed Spark. So data, the main purpose of the data proc is to run your Spark and Hadoop jobs. The main purpose of the data proc in the life is to run the Spark and Hadoop jobs. So you can able to run Spark jobs and Hadoop jobs. The advantage with the data proc is that you can just tell to the data proc that whatever the machines I wanted to create. For example, so if you wanted to create a cluster, you can also see it here. A data proc lets you provision Apache Spark cluster and connect it to the underlying data analytics stores. So for example, if you wanted to create a cluster in the on-premises, you spent a lot of time, right? Now you see it. If you wanted to create a cluster. So you can actually create a cluster on top of the compute engines, nothing but a virtual machines. Or you can also create a cluster on top of the Kubernetes engines. Okay, I'm going with the compute engines, nothing but a virtual machines. Provide your name for your cluster. We are creating a cluster, sir. Now we are creating a cluster. Now see the cluster name I'm giving as in demo. I'm giving the name of the cluster is a demo cluster. You can select any location, and now see here. So while you are creating a cluster, as we already know that, so cluster is a comprises of machines, collection of nodes, master as well as worker. So now you see here. Do you wanted to go for standard cluster? A standard cluster can be a one master, n workers. N can be anything. N can be 1, 2, 3, 4, 5. And single node cluster, where there is only one master, zero workers will be there. Where if you have a very simple task, small jobs, then you can go for one master. Master can able to take care of it. And high availability means three master and workers. For a very large jobs, you can actually go for these things. For now, I am going with the standard. One master, I'll be having one or two or three workers. Okay, we have given a cluster name, cluster location, auto scaling, networking, all of these things are not required. Okay, enable component gateway. Sir, while the cluster is created, we already know if the cluster is created, it already comes up with these things. Okay, Spark, MapReduce, HDFS. Additionally, if you wanted to create any component gateways, like you want Hive, sir, I want Jupyter Notebook, sir, I want Presto. So if you need any of these softwares on top of your cluster, you can go for it. So if you need Docker or HBase, all of these things, if you need, you can enable all of these things. Okay, I for now I'm just enabling the Hive and Jupyter. Okay, yeah. So enabling the component gateway is that additionally, if you wanted to add any of the components for your cluster, that means if you enable these things on top of your cluster, all of these things will be pre-installed. While the cluster is creating, it will also be installed on top of your cluster. Okay. Yeah. In addition to what, sir? In addition to the existing softwares like Spark, MapReduce, and HDFS. Okay. Now, sir, we have only mentioned here one master and worker, sir. But master machine, I need to provide some configuration. My workers also, I need some configuration where I can do that. So once you have done all of these things, if you see the left side, you can click on configure nodes. Okay, here it is manager node. Here it is worker node, manager node. The series you can select here. Machine series, N1 series, machine type, N1 standard 2 or anything you can select anything, sir. Okay, N1 standard 2, N1 standard 4. So you can see here 2 GB, 13 GB, 16 to 104. So according to your requirement, you can select anything, sir. Okay, now I am selecting N1 standard 2. Okay, 2 CPUs, 7.5 GB memory. So master machine configuration is this one. N1 series, N1 standard 2 is the machine type. 2 CPU, this one. And disk size is 50. We just need 50, not more than that. Okay, so all of these things, configuration for the manager is done. Workers. Workers also I will select a machine. N1, N1 standard 2. Number of machines. Number of worker nodes. 2, sir. I have mentioned 2. So if you need 3, you can mention 3 also. If you need 4, you can mention 4 also. Okay, I just need 2 only for this demo purpose. Okay, number of worker nodes. Disk size 50 is enough. 50 means 50 plus 50. One machine will be having 50, one other machine will also be having 50. So that means 100 total. Okay, so this is how you provide the configuration for the master node as well as a worker node. You select the series, you select the machine type, you select the number of worker nodes, you select the disk size. Disk size means nothing but a storage. Okay. So once you have selected all of these things, if you wanted to customize your cluster, if you wanted to add any initialization actions, you can add it here. Okay, cloud storage staging bucket. If you wanted to select any staging bucket, you can select it. Okay, so I'm going to select 36 as my storage staging bucket. And if you wanted to enable the schedule deletion or this thing, you can also enable it. I'm not enabling anything. So these are all things related to the security. We need not to worry about it. So cluster name, location, cluster type, like with optional components, configuring the cluster with the help of the master configuration as well as worker configuration, and the staging bucket. Okay, all the things I have created, and I click on create. I can click on create. And if you wanted to see equivalent command also, if you wanted to see, you can able to see it here. So this is the equivalent command for this one, sir. Okay, so tomorrow I wanted to create a cluster. So close it. So you can see here, if you wanted to create a cluster from your cloud shell, you can also create a cluster from the cloud shell as well. Okay, so this is also you can come. Okay, so now if one wanted to create a cluster, so doing all of these things is a heavy job. So because setting up the name, cluster node, all of those things is a time taking process. So if you wanted to create your cluster, you can actually create from your uh, cloud shell as well. I'm going to get a cluster from cloud shell. I'm going to activate the cloud shell because you already know if you just click on create, a cluster will be created. Okay, so if you wanted to create a cluster from the cloud shell also, I will try to tell you. Okay, so I have the code ready. So you can see here, if you wanted to create a cluster, create data pro cluster, single node cluster, you can just copy this thing. For multi-node cluster, you can copy this thing. Okay, single node cluster and multi-node cluster. Okay, so I'm going with the multi-node cluster. Let me copy it and try to tell you, explain you guys. Okay, if we have any, okay, so I think it is good. Okay, see here, cluster name I have given as a variable. Region also I have given as a variable. Cluster name I have given as a variable, sir. Cluster name is equal to this is my cluster. Tomorrow, if you wanted to change your cluster name, you can just say I will just say like demo cluster one. Okay. Region. Tomorrow, if you wanted to change it to your central one, you can change it here. Say the code for creating a cluster. G cloud data proc clusters. This is a command. Create. So you mention the cluster name. You mention the region, number of workers, configuration for the worker, disk size for the worker, master machine type, master disk size, image version, operating system, Debian. Do you want it to enable the component gateway? Yes. What are those? Jupyter Notebook. Initialization actions. If you have any if you wanted to do any of the initialization actions, you can do it. So I'm installing the BigQuery connector as well, sir. I'm installing the Spark BigQuery connector as well. You can see here. Okay, I'm installing the Spark BigQuery connector as well. So this is also you can mention. So if you wanted to mention these things in while creating manually, where I have to mention, sir. If you wanted to create these things, you can go to customize cluster. You can see initialization actions. You can add it here, and metadata you can add it here. Okay, so this is how it is. Initialization actions as well as custom metadata. So what I will do, I will also in the companies also they don't manually create anything. They actually automate it using this thing only. Copy this thing. My cluster name is demo cluster one. Go here, click on enter, paste here, click on enter. Authorize it, and you go back and wait for some time. See here, cluster demo cluster one is getting created. You can also see here, waiting for the cluster to be created. So whatever we do manually select it, we can also do it with the help of this code. So I suggest you to guys create your cluster using this thing only. Using this thing only, you can create it. You have the nodes access already. So if you wanted to create a single node cluster, go for this code. Multi-node cluster, go this code. Those who wanted to go create it within 3 machines, they can mention here 3. Disk size, if they wanted to increase different machine, if they wanted to increase, they can change it with the different machine names as well. This is just you can actually change it according to your requirement. Okay. Now let's I'm enabling some APIs. So here it has mentioned API hasn't been enabled, so I'm enabling it. Anyway, the cluster will be created. That's not a problem. Let's wait. So it takes actually 4 to 5 minutes. Usually, if you wanted to create a cluster handling all of those things in the on-premises, you take months. Companies takes months. Organization takes at least months 1 month to 2 months to create a cluster, manage all the details, infrastructure details, backup, networking, storage, all of those things they take a month. Now you are creating a cluster with your required configuration with the auto scaling capabilities, all of those things within 4 to 5 minutes. So that's the reason Data Proc, Databricks, Elastic EMR, all of these things are very famous because this provides you the managed Hadoop and Spark cluster data processing, so that you need not to manage anything manually. All the things will be automatically managed by the cloud providers itself. Okay, yeah. So once the cluster is created, what we are going to do is that, so once the cluster is created, so all of these softwares will also come, and we have mentioned some Jupyter notebook as a optional component that will also be installed in the cluster. And that next we have to focus on this thing. Next we have to focus on this thing. Okay, so for example, you wanted to do some kind of it, you wanted to create some pipeline, or you wanted to create some data processing system to read the data from some platform and do the data processing, nothing but to transform the data and load it to the destination, right? So all of those things you have to mention in your code. Okay, then you mention in your code. Once you mention in the code and once you run this code, the data processing activity will be running and the data will be clean, and the data you can send it to the some BigQuery or something for the analysis purpose. So that is what we are going to do. Okay, so for reading the data from, you can actually read the data from some JSON, CSV, Parquet, Avro, all of those examples I will tell you. You can write the data to the these formats, or you can write the data to your destination like BigQuery, Google Cloud Storage. I will also tell you that. And transformations also we are going to learn step by step, like adding the column, renaming the column, creating a structure properly, creating a schema properly, and aggregations, joins, all of those things we are going to learn group by all of those things. So once the cluster is created, we will be focusing on first reading the data, next writing the data, then we will be focusing on the transformations. Because transformations are many things are there. Okay, so this is how we are going to learn the Pyspark. So we are going to focusing on this one is with Python with Spark. Okay, so this is what is our Pyspark. In our course, we are focusing on the Pyspark only. So you see here, the cluster is created and the cluster is running also. Okay, click on this cluster. And you see here, cluster is created. You can able to see the dashboard for ARN and network CPU utilization, all of those things. You can able to monitor your activities here. And you can see here, any jobs running, have you submitted any pipeline? Job is nothing but a workflow or a pipeline, sir. Have you submitted any job? No. And you already know how many VM instances we have created. One master plus two workers, right? You see here, one master plus two workers. And configuration, if you wanted to edit the configuration, feel free to do that. You can able to see it here. The configuration is edited here. Okay. And web interfaces. We already know Yarn will be installed, MapReduce will be installed, Spark will be installed, HDFS will be installed, and Hive is also installed. So Jupyter is the one which we have enabled the component gateways. See, all the component gateways are enabled. Additionally, Jupyter Notebook is also added. Jupyter Lab is also added. So click on this Jupyter Lab. Click on the Jupyter Lab. So I clicked on the Jupyter Lab. It's opening here. So Jupyter Lab. A Jupyter Lab is the one where we actually do everything. Here we can do everything, sir. Okay, you see here. Do you wanted to create a Python notebook, Pyspark notebook, R notebook, Spylan kernel, or console? You can also go to the notebooks. So notebooks gives you the very good UI to create your code and work with the code and process your code. Console is also there, but it gives you less of a user interface. I am going with the notebooks and I am going with the Jupyter PySpark notebook. This is a notebook is nothing but a Jupyter notebook, sir. These are the Jupyter notebooks. These are the consoles. Console is nothing but a how our cloud shell looks like. Okay, notebook. Let us see how the notebook will look like. So you can see it here. Click on the PySpark. When I click on the PySpark, right? See, you need not to install the PySpark also. You can also see here. So import PySpark. If I say, automatically it will work. Let me increase the size. Okay. So when I click on import PySpark, right? So automatically it will be installed. See here, when I click on import PySpark and enter, automatically it is running. That means PySpark is already there. You need not to check it. See here, PySpark is already there. So the advantage that you are getting from the data proc is that you don't need to create the cluster. You don't need to install the softwares manually. A PySpark is also comes up with a pre-installed, right? So these are the advantages that you get. And now, okay, so whenever you are working in this, whenever you wanted to work with the PySpark, the very first thing is that whether it is there or not, we try to import it. So import the PySpark. So this is where first step is. 1 minute, guys. Give me 1 minute. So okay, the very first thing is that we import the PySpark module. Okay, so this is what is our first step. So once the PySpark is installed, you can also check your Python version if you wanted to check it. If you wanted to work with another version also, you can able to work with it. Sorry. See, Python version is this one. You are working with the Python 3.8.15. Okay, you can also see whether the Spark is installed or not. So Spark is also installed. Just to check, just to make you aware that all the Spark object, everything is created and Spark session is also there. But it's a good practice to check all of these things whether they are available. But before that, I know already all of these things are there. So this is our first step, sir. Okay, importing the PySpark. And after that, create Spark session. Second is one, create Spark session. We need to create the Spark session. What is a Spark session, sir? We are creating a Spark object and we are creating an application. So all the things we are going to use it here. A Spark session is an entry point to yours. Pyspark application, whatever the code you are running, right, this is an entry point. So you need to create this, import the Spark session and create a Spark session. Okay, for that, I'm going to import it first from pyspark.sql, import Spark session. Okay, now Spark is equal to Spark session. One day I will tell you the difference between, maybe tomorrow I will tell you the difference between the Spark session and Spark context. Spark session.builder, app name. You are building some application, right? So the app name you can say Spark demo. Slash is nothing but a line continuation. Guitar create. This is a one-time activity, sir. Don't think, sir, what is this one and all. Don't think that this is a one-time activity. So we need to work with so we need to tell the Pyspark that we are doing this thing. So this is an entry point to your Pyspark session. So that's the reason Spark session is an entry point to your Spark application. We must create the builder. So this is how we create an object. So this object you are creating. So if you don't run it also, you have a Spark object. Do we have to create manually? No. So this is a best practice, guys. This step is a best practice. You don't need to actually create a Spark session. All the Spark session is also comes up with a cluster only. So it is already created. So it's your best practice to know that even when you are working in the on-premises also, this is how people will be creating a Spark session. Now I will be running it. For running it, Shift plus Enter, sir. For running it, Shift plus Enter. Okay. So you can see here it is ran. So you mention everything again. It's a Spark session only. We created a Spark object, right? So Spark object is given to the Spark cluster by automatically. You don't need to actually create it, but it is a good practice for us to create the Spark object. Okay. So that's how we have created a Spark object. So these are the first steps. Okay. Once you have imported your model and created your Spark session, so that's where the both of the steps are completed. Now you don't need to worry about anything. Sir, I have some data set, I have some schema, I wanted to create some data frame. How I can do that, sir? So first I'm going to tell you how to create data frame from, okay, we are creating a data frame, sir. Okay, so I would just say we are focusing on data frame only. So data frame creation. Okay, so I would just say markdown. Okay, so this is how it is. So far, these are the importing and Spark session. This is, even though we don't do it or even we do it also, that's fine, because Spark data proc comes up with all of these things pre-installed. Whether you follow the step one or whether you follow the step two, it's not going to worry much. But the only thing is that we are focusing on the data frame creation. Let me tell you, for example, if you have a sample data, assume that, sir, I have a sample data like this. Okay, I have a sample data like this. Assume that I have a sample data like this. Okay, data is 1 Anil, 2 Sandeep. Okay, it's a CSV kind of a data, comma separated data. So for that one, I have a schema like this, sir. Okay, for this one, the schema is like this. Okay, so I have a data, I have a schema. Okay, data schema. So for that one, I wanted to create a data frame. Okay, now I am creating a data frame. Create a data frame from hard-coded values. So these are the hard-coded values. Okay. So for creating a data frame, it's very simple. So if you wanted to create a data frame one, Spark dot create a data frame. You give the input data, comma, you give the input schema. Okay. And if you wanted to see the data, you can just mention data frame dot show. And if you wanted to print the schema, you can just print schema. Okay, so this is how you can able to create a data frame, and you will be able to see the data also. Now let us wait 1 second. Okay, you see here, see whenever this code is running, it becomes star, and whenever it is processed, the consecutive number will be running. Okay, so that is how it is. You see here, sir. So I have this data and schema column names. You can say instead of schema, you can just say column names. Columns. I will just say columns. For now, it is just column names. Okay. Now you see here, we have created a data frame. This is our data frame, sir. Okay, this is our data frame. And you see here, we have created a data frame from the hard-coded values, and we can able to show the data frame. We can able to print the schema also. Okay, so this is how we can able to create a data frame from the hard-coded values. Anyone have any questions on this one, guys? Hope you all are able to hear me.
Able to hear, able to understand.
Yeah. A bit different. It's not. It's very similar to Pandas framework. Pyspark is very similar to the Pandas framework, and the syntactically little different. That's it. Syntax, yes. So pandas is only a single machine, right? The main difference between the pandas as well as PySpark is that syntactically there will be a little difference. Language to language, there will be a little difference. Pandas comes from the Python, and PySpark also comes from the Python. Syntactically, there will be a little difference. There you can able to show and print schema. Little difference will be there. But when it comes to the infrastructure point of view, pandas only work with the one machine, but PySpark can work with a cluster. Okay, so that's the main difference. Now we have able to create a data frame from the hard-coded values. So if I wanted to create a data frame, from CSV file. So if you wanted to read a CSV file, I wanted to create a if I wanted to create a data frame by reading a CSV file, we can also do that. So let us try to do this activity as well. Assume that if I have my CSV file in some other location. Okay, so assume that. So that location can be in the Google Cloud Storage. I'm taking the cloud storage. Okay, let me take any of the bucket, source bucket, let me. And if I do not have any files here, so let me delete it. I do not have any files here. So if I have some file here, for example, let me upload one file. Okay. Okay, let me upload my file, sir. You see here, I'm uploading my CSV file. Okay, drag and dropped it here. And dragged and dropped it here. You see here, order items.csv. Okay, sir, I wanted to read the data from the Google Cloud Storage and one of the file that is there in the one of this bucket. Okay, so let us try to read that. So let us try to mention the path first. So the path is source or input path. Input path. So I am creating a first input path, sir. My input path for this file is that when you click on the file, and you will be able to see that gsutil URI, just to copy this path. Okay, copy this path and paste it here in the quoted. Paste here in the quoted. This is your input path. This is your CSV file which is there in the Google Cloud Storage. Okay, and you wanted to create a data frame too. data frame 2 is equal to. Now, whenever you wanted to read the data from a CSV file, this is how we are going to use it. Spark.read.csv. Okay, spark.read.csv. Now you can mention your input path here. Okay, you can mention your input path here. Let me show you how it looks like. df2.show. Okay, enter, shift enter. See, we are able to read the data from the CSV file which is there in the Google Cloud Storage. That means we can able to read a CSV file and create a data frame. Now tell me, what is the problem with this data frame, sir? Can you guys tell me what is the problem with this data frame?
Column names.
Column names are here, right? But it is taking a, it assumed that the column names is also a data, right? So we should mention, while reading the CSV file, you can mention header equal to true. When you mention header equal to true, automatically what will happen is that this, in this CSV file I have a header, the first line is header, so for that one you will mention header is equal to true. That means the first line it will be treating as a header. See here. So that is how you can able to create a data frame from a CSV file. Now let me print the schema also. See here, sir. What is the problem here with the schema? Now, do we need that? See here, for example, if you look at the order ID, is it a integer or a string? Integer. So these almost all the things are integer or a float values. But by default, if you don't mention your schema, it will be taking everything as a string. So there are two ways of tackling it. I'm going to tell you one way today and tomorrow one way, which is tomorrow whatever I'm telling you, structure type and structure field, those are the important thing. Whatever I am telling now, that the Pyspark I am telling to the Pyspark is that you infer the schema from the file. You infer the schema from the file. Okay, infer the schema from the file. What I am telling to the Pyspark is that you read the each column. Pyspark, you read each column, and based on the data of the column, you come up with a one data type. Okay, that's what I'm telling to the Pyspark. So that line is this one. Infer schema is equal to true, nothing but a, you go to each column and look at the data. According to the data, according to the values, you select a better data type, best data type for that particular data. So for that one, I have selected it. Click on this one. Now you see. See, ID is taken as an integer, 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 and double, nothing but a float. Perfect. So this is one way. So the Pyspark is actually selecting the choosing the data type as per the data. But we don't want this one also, because tomorrow I want this to be a float, but it is taken double. Double and float are same, but I want my client to should not be confused with the double and float. I want this to be a float. You wanted to specifically mention your schema properly. Tomorrow I will tell you that how we can able to specify the schema with help of the structure type and structure field. Okay, so this is what it is. But now you got one thing: how you can able to read the data from the GCS, how you can able to read the data from the CSV file, how you can able to create a data frame from the CSV file, and how to enable the header is equal to true, how to infer that schema is equal to true. All of those things we have done it. Correct? Any questions? Okay, so here it was hard coded data. Here it was from the CSV file from the GCS. Okay, CSV file which is there in the GCS. Now the same thing, not CSV file, it is JSON file. Okay, so earlier it was CSV file, right? Now it is a JSON file, sir. Okay, now it is a JSON file. how to read the data from a JSON file. Okay, so let me keep some JSON file inside this one, inside my bucket, if I have it any. Okay, if I do not have anything, it seems. Okay, sample JSON, I do not have any sample JSONs. Seems like I do not have anything. Let me JSON, yeah, I have it, I have it. Okay, let me open it for you. Okay, let me check it. Okay, let me try to. Okay, 1 minute, let me load it. I'm dragging and dropping it here, guys. Okay, dragging and dropping it here. Okay, so you can see here employee.json. You have a JSON file also. Click on this one, copy this thing. Same thing, I'm going to copy this entire thing, sir. Okay, I'm going to copy this entire thing and paste it here. And here, this is not a CSV. I'm going to copy the path here. This is the copy and paste it here. Okay, and spark.read.csv it is there. But what is the file format that we are working with? So you just change it to the JSON. That's it. Okay, so for JSON it will not work, but let me show you how the JSON looks like. Okay, this file, how it looks like, let me show you. Sorry, it's not opening. Okay, this is how the JSON files are. So it is having name, it is having age. Only 1, 2, 3. Three fields are there. 3 rows are there. One is name, two columns are there. Name and age are the 2 columns, 3 records are there. Okay, so it is having, it's already the column names, right? So that's the reason if I try to mention the header is equal to true, it will throw an error, you see. JSON unexpected keyword header, because JSON does not have any header, automatically JSON file will be having its own header. Okay, you can just click on this thing. See here, 3 columns are there. 2 columns are there, 3 records are there. Name, this one. So this is how you can able to see it. So this is long, this is integer, this is string. So that is how you will able to create a data frame from the JSON file as well. Okay. Any questions, guys? And tomorrow I will tell you. So tomorrow I will tell you, create a data frame from packet. And after that, what I will tell you is that create a data frame from the database. Okay, reading a table, database table. Okay, so if I have some table in the database and I wanted to read it out and create a data frame, I will tell you that as well. Okay, so this is also I will tell you, and create a table from the BigQuery also. BigQuery. Okay, all of these things I will tell you tomorrow, sir. Okay, so this is the read concept. Okay, that's the reason I will tell this is a read session. Session name is session 1 underscore read data. Okay, read data and create a data frame. Okay, so that is what it is for this session, sir. Okay, so far what we have done is that we imported the Spark, we created a Spark session, created a data frame hard-coded values, created a data frame CSV file, created a data frame JSON file. Tomorrow Parquet file, database and BigQuery, all of those things that we will see tomorrow. Okay, Yeah. Any questions?
Yeah, we can write the program in Scala
Wait
Spark
a minute.
also.
Wait a minute. Wait a minute. Wait a minute. Two people are talking. Please raise your hand if you guys have any questions. Okay. Please raise your hand, guys, if you have any questions. Yes, Nagaraj.
Yeah, we can write program in Scala also,
No,
na,
no,
in
no,
this.
no, no. Wait, 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 wait. Okay, there are two Nagaraj. Okay. Nagaraj T. Okay. Yeah, you can just mention here automatically. You copy the path. Okay. Usually you can mention Excel is a tab separated actually, but you can, for example, tomorrow I will show you Excel also. You can just copy it and paste it automatically. You can mention CSV text. You can mention here TXT. Okay. Automatically it will work. That I will show you tomorrow. Okay. So master is something like, when it comes to the workers, it will just look after, it will track all the information. Okay, what the worker is doing, and how much job has to be taken, how much data we have sent it to the this particular machine, and from where to where, and from how many days, and all of those information it will be tracking. And the yarn is nothing but a cluster manager tool. It will be mainly focusing on the master. Mainly it will be getting the data from the master only, because master already storing all of that information. And how much data, because you see, master will, for example, if you have 100 GB in the worker, and master has sent some kind of a 50 GB only, that means master will track that 50 GB of the work is stored in the worker machine. 50 GB of the work is stored in the worker machine. The cluster manager will read that information saying that, okay, so 50 GB is allocated, 50 GB of the data is already stored in the worker machine. That means rest of the 50 GB is idle. Okay, so it will think like that, and it will send the some more data to store it there on the worker machine. So cluster management tool is something that it will be look after entire cluster, and to get that information, all the details will be stored in the master, as well as all the details will be stored in that particular cluster. So all of the details it will be reading, and based on that it will be taking its own decision, so that multiple jobs can run on a single cluster. So it will make sure that it will run multiple jobs will on cluster, so that there will be no machine will be idle. So that's what the main purpose of the cluster management tool. Yeah. No, no, no. I mean, it depends. There will be plenty of the clusters. It depends. It depends on the requirement. Sometimes people will be creating one cluster with a heavy, and people will be having many clusters. It's not one always, more than one. Okay. And yes, Nagaraj L.
Yeah, we can
Yeah, no,
write
no.
program in
I,
Scala also, na, in this terminal.
no, no, no. We have one more guy. Yes, Nagaraj. Any questions, guys? Are we good? Okay. Yeah. Okay, guys. Thank you all. We'll see rest of the things tomorrow. And don't delete your cluster, or don't keep it idle, because as soon as you create cluster, the cost will be calculated. So try to stop your cluster. Okay, try to stop your cluster or delete your cluster. Okay, don't keep it idle. If it's keeping it idle, the cost will be calculated. There will be money will be debited from your free account. So stop your cluster or delete your cluster. Anything you can do. Okay. Okay, guys. Thank you all.